Okay, good day, guys. So in this video, we're going to be looking at calculus and we're going to focus on the first principle. So in your question paper, they can give you a question which says determine the first derivative from the first principle. So once they tell you to determine the first derivative from the first principle, you're going to use this type of equation. So let's just indicate it. So you're going to use this type of equation whereby it says the first derivative f prime x is equals to the limit of h as it approaches 0, f x plus h minus fx divided by h. So this is the key equation that you're going to use when they say derivate or first derivate using the first principle. So let's just look at an example now and keep in mind of this equation. So they say now determine f prime x, which is the first derivative from the first principle if we are given a function. So here, if you can check now, they've given you the function. But what's nice about this function, you can use this function to get what you want. So in this case, we have f at x. Yes, we have this one. Let me just indicate it. We have this one, f at x, and this is the original equation that they've given us. But now we need to find fx plus h. So how are we going to find this fx plus h? We're going to use the same equation that they've given us. We're going to come back here to say now fx plus h is nothing else but equals to. So what you're going to do here, where there's x, you're going to put x plus h in this case. So which means now we will have something like 2 open bracket, where there's x is going to say x plus h close bracket, and then this squared remains. So once you have done here, you can just simplify this because we don't want to put a complicated equation like this here. So let's just simplify this problem. So we're going to have something like 2 open bracket x. Okay, let me just open 2 brackets. xx and then h positive and a positive. So what we're going to do here is just to say 2 open bracket, and I'm going to simplify this for you. So we're going to get x squared plus 2xh plus h squared. So when you simplify this, you're going to get something like this. And then once you're here, you carry on, use your math. So it's 2, and then let me just do like this. Let me just see. Here we're going to use the distributive property saying 2 multiplied by x squared, 2 multiplied by 2xh, 2 multiplied by h squared. So 2 multiplied by x squared is 2x squared. 2 multiplied by 2xh is 4xh. 2 multiplied by h squared is going to be 2h squared. So once you are here, look at this. Now you have found this fx plus h. So your thing is to now take this fx plus h and go substitute it into the original equation. And also this f at x, you're going to substitute it where? Here. Now let's just proceed. So what we'll say now is to say the first derivative of x is equal to the limit of h as it approaches 0. So where there's fx plus h, we're going to put this one. So it's going to be 2x squared plus 4xh plus 2h squared. And then where there is f at x, we're going to put the original f at x, which is 2x squared. So let me just say minus. This minus comes from the equation, open bracket, and then this is just 2x squared, close bracket. And then this is all over h. So once you're in this equation, you just carry on with this limit as h approaches 0. Now it's time for you to simplify. So, but look at this. There's something interesting here. This 2x squared and this minus 2x squared, they can cancel one another, and we will be left with nothing else but 4xh plus 2h squared divided by h. Let's just proceed. So we're going to be left with this limit as h approaches 0. And then here, what we can do here is very simple. So here we can factor out a common factor. In this case, the common factor is h and h. And then here we're going to have h open bracket. The thing that is going to be left is just 4x and then plus. Then we'll have 2h. And then if you can just cross distribute this inside the bracket, this h inside the bracket, you will go back here. So everything is correct so far. So this is nothing else but divided by h. So once you are here, what you can do is very simple. This h will take this h. What are we going to be left with is just the limit of h as it approaches 0. And then we're going to be left with 4x plus 2h. So once you're in the step, in order for you to remove this limit as h approaches 0, where is h? So let's just do like this. Where is h? Where is h? You're going to put 0. This 0. And then let's just do it. And then once you do that, and you don't need to involve this limit as h approaches 0. So we're going to have something like 4x plus 2. And then where there's h, obviously we're going to put 0 and then close the bracket. Then is equals to, this is equals to 0. So we are left with 4x. Just put it very clear so that you can see it. So our solution is just 4x. So once you've found this answer, you've actually found the first derivative from the first principle, and you're gonna get all your marks. So let me just show you how they give you marks. Usually this question is around 5 marks. This is how they're gonna give you marks. So they know that you understand that we have to find fx plus h. So you're gonna get a mark there, and then substituting it in the equation, they're gonna give you a mark, and then probably they're gonna give you a mark there, and then also the answer, and also here whereby we remove this, the limit of h as it approaches 0, by replacing this h with 0. So in total, you're going to get your 5 marks. So this is how you can get your 5 marks on calculus.